Problem is from GATE 2020 mathematics paper, question number 6. The problem given is, let f of z equal to e to the power of 1 by z, where z is the complex number in C except the point 0, and let for n belongs to n, Rn is the set given as the set of all complex number z that equal to x plus iy in C, such that mod x is less than 1 by n and mod y is less than 1 by n, minus the singleton set 0 is Rn. If for a subset S of C, S bar denotes the closure of S in C, then the four options given are f of Rn plus 1 whole bar is not equal to f of Rn. Second option, f of Rn whole bar minus f of Rn plus 1 whole bar equal to f of Rn minus Rn plus 1 whole bar. And third option is f of intersection n equal to 1 to infinity Rn whole bar equal to intersection n equal to 1 to infinity f of Rn whole bar. And option D, f of Rn whole bar equal to f of Rn plus 1 whole bar. The NPTEL reference to solve this problem is module 6 of lecture 3 of module 6 of complex analysis. The title of this lecture is Essential Singularity and Introduction to Lorentz Series by Dr. P.A.S. Sri Krishna, Department of Mathematics and IIT Guwahati. The NPTEL reference, even you can watch this NPTEL reference video using this YouTube link. So now coming to the solution, it is given that f of z is equal to e to the power of 1 by z for z in C minus singleton set 0, and the set Rn given as the set of all complex numbers z that equal to x plus iy, such that mod x is less than 1 by n and mod y is less than 1 by n, minus the single set 0. What does this mean is, the set Rn is nothing but taking these two axes are x and y axis and the whole as complex plane. We have these points are 1 and minus 1 around, and this point is I and this point is minus I approximately. Then the set Rn is given as so this is the set R1, and whereas we have to remove the point 0. And coming to the set R2, we have, so this is 1 divided by 2, this is minus 1 divided by 2, and by assuming this as I divided by 2, this point as minus I divided by 2, we have the set R2 as this set. And similarly, by doing the same thing, we get this as Rn approximately for all natural numbers n. So we get this as 1 by n, this as minus 1 divided by n. So we get, from this we can see, so we have Rn plus 1 is properly contained in Rn, and Rn is an open set, which can be seen as the set given is this. So which can the set Rn is open, can be seen easily. So now coming to the function f of z, since f of z is given as e to the power of 1 divided by z for z in C minus singleton set 0, which can be written as 1 plus 1 divided by z plus 1 divided by z square into 2 factorial plus 1 divided by z cube into 3 factorial plus and so on. This is just by the expansion of the exponential function e to the power of 1 divided by z. And from this we can see the function f of z has, so f of z has essential singularity. At the point z equal to 0, we can see. So now to solve this problem, we use the Casorati-Weistrass theorem. That is, whenever f of z has an essential singularity at a point z equal to a, then in every neighborhood of a, the function f of z attains almost close to every complex number. That is, since f of z has analytic, sorry, f of z has essential singularity at z equal to 0, and as 0 does not belongs to Rn for all n, and by Casorati-Weistrass theorem, we have the image of the set Rn under the function f is dense in C. That is, the closure of the set f of Rn is dense. Dense in the set, its closure is nothing but C infinity, the whole complex number, extended complex plane C infinity. That is, and this is for all n belongs to n natural numbers. So from this we can say f of Rn whole closure equal to f of Rn plus 1 whole closure equal to C infinity. Yes, this condition holds for all natural numbers n. So by looking at the options, we can say the first option. Okay, coming to the fourth option is correct. But whereas coming to the first option, we have f of Rn plus 1 whole bar is not equal to f of Rn. What is the question here? That what is f of Rn? Since we know about the closure of f of Rn, but we don't know about the about f of Rn. So since it is given that the function is f of z is e to the power of 1 divided by z, and we know exponential function never attains the point 0. So since exponential function never attains 0, so f of z that equal to e to the power of 1 by z is not equal to 0 for all complex numbers, for all z in C. And so 0 does not belongs to f of Rn. So whereas we have f of Rn whole bar equal to whole of complex plane, extended complex plane. So from this we can say, so f of Rn whole bar is this is as C infinity, whereas 0 does not belongs to 0 does not belongs to f of Rn. So we can say f of Rn whole bar not equal to f of Rn. So we can say first option is incorrect. But whereas coming to the second option, we can see the left hand side thing f of Rn whole bar minus f of Rn plus 1 whole bar is nothing but empty set. Whereas coming to the right hand side, f of Rn minus Rn plus 1 whole bar. That is from this map, from this image, we have f of, on the right hand side thing of the option B, we have f of Rn minus Rn plus 1 whole bar. That is Rn minus Rn plus 1. So whereas coming to the case when n equal to 1, we have R1 minus R2. So we get this neighborhood. But whereas since it is non-empty, so we get some, at least some points in it, in the image of the function, image of of this set under the function f. And of course, since f is analytic, its closure is non-empty. That is, since f of Rn whole bar minus f of Rn plus 1 whole bar equal to empty set. Since both these sets are same, that is C infinity. But whereas f of Rn minus Rn plus 1 is non-empty, and since f is analytic, so f of Rn minus f of Rn minus Rn plus 1 whole bar is non-empty. So we can say f of Rn minus f of Rn whole bar minus f of Rn plus 1 whole bar is not equal to f of Rn minus Rn plus 1 whole bar. So option B is incorrect. Whereas coming to the option C, we have intersection n equal to 1 to infinity Rn. That is nothing but empty set. From this map, we can observe that. So under the function f, empty set is empty set. So hence its closure is also empty set. But whereas coming to the right hand side thing, we have, since image of f of Rn whole bar is C infinity for all n equal to, for all natural numbers from n equal to 1 to infinity. So that is, this is nothing but empty set. But whereas coming to this set, it is, this is equal to empty set. And whereas coming to this, we have intersection n equal to 1 to infinity. This is C infinity for all natural numbers n equal to 1 to infinity. So these two are not equal. So we can say so 0 empty set is not equal to C infinity. So we can say option C is incorrect. So we can say in total, the only option correct is option D. Thank you.